Hey, welcome back. We're going through the Ultimate Go tour here, and this is kind of teaching us a lot of cool things about Go. You could get here by going to tour.ardenlabs.com/tour. And this video, we're going to go through variables here. We're going through the language mechanics. And with variables, we're going to learn all this stuff here. And I've put together a summary of what, what the main points are that we're going to learn. And so those main points are right here. And so just for a second, I want to zoom in and show those to you. But before I show them to you, I want to show you the code that we're going to take a look at. And so here's the code we're going to take a look at. And like the main takeaways here with learning about variables is, when you program in Go, you really want to think about like what's going on with the machine. So the hardware is the platform. Some programming languages like Java have like a virtual machine. So there's like, the Java runtime, and then what you write up here is running on the runtime, and then the runtime is running on the hardware. But with Go, you're coding right to the hardware, which is super cool. And so you want to think about what is going on with the machine. And so when we talk about variables, this first step here in the Ultimate Go tour under language mechanics variables, and we're going through step 1 of 2 there. When we talk about variables, one of the things we really think about is Go is a statically typed language, and when you declare a variable, and we're going to learn about declare and assign and how that's equal to initialization. So we'll learn just to be precise with the language that we use to talk about the Go programming language. So every programming language has a language that you use to talk about the language. And precision is important. So learning the difference between declaring and assigning and how that's equal to initialization and what that means and how it relates to the zero value. And then also, right, when we talk about variables, this step right here in the first step of language mechanics, we think about like what is the type? So what is the type of the value that this variable is going to store? And so type is really important. Type is life. My friend and mentor in the Go programming language, Bill Kennedy, and this is Bill's company right here, but he says type is life. And he threatens every now and then to get the tattoos TYPELIFE on his knuckles. So I doubt he'll ever do that, but it's a good joke. But we really think about what is the type, right? Go is a statically typed language. And I put together some notes which are in the code base here. And so the code base is at GitHub, and I'm just looking for GitHub here. And you could go to goes to 11. So let me just get back up to the top of this. I hope I didn't click that. That's not where I want to go. Goes to 11 at GitHub, learn to code Go version 3. And so scroll down to the 0, and it's like B something. So here it is right here. It's 000 BRBK Go tour. And if you open that up, we're in 03 variables. And then in here, I put together this really nice outline where there's a lot of really great things to take a look at, including this really cool quote from a friend of mine who's a developer. We were talking the other day and we were talking about Go, and he said, man, Go is easy to learn and hard to master. And I was like, that's a great quote. So there's that quote from my buddy Andrew. But this outline here and this README will talk to you about declare, assign, initialize, and zero values, and then also so that it talks about static and dynamically typed. That's why we came here. Statically and dynamically typed languages. So we have declare, assign, initialize, zero value, built-in reference, and struct types. And then we have string is a built-in type, and we learn about the underlying data structure of a string and the underlying data structure of a slice. We learn about zero values through here, and value semantics and pointer semantics. You start to be introduced to that, and conversion versus casting and the difference between those two, and why we really don't do casting in Go. You can do it if you really need to using a package called unsafe, but you could do conversion to your heart's content. And why? Why is the difference between conversion and casting? So there's some really good things to think about when you start thinking about variables and type. Right? Type is life when you start thinking about variables and type in life. Type is life. And then a little bit that is here on the Go language. So I just put all this together, and there's the part about static type versus dynamically typed language. And so I really recommend going to this README here, and goes to 11, learn to code Go version 03, and then 000 BRBK Go tour, and then 03 variables 1. And there's that README right there, so you can check that out. So let's take a little bit of a look at the high level overview of the main points here. But when you declare a variable to be of a certain type, so I could declare the variable x to store values of type int. My dog's saying hello too. Right? Type tells us two things. It tells us what type of a value is going to be stored using a memory address, and then how much memory is going to be used. How much memory is going to be used to store that value. And so that's really interesting to start thinking about, is like memory usage. And so just right out of the gate with Go, you want to start thinking about memory usage and how is memory being used, and what is the heap, and what is the stack, and what's the difference, and when do you escape from the stack to the heap, right? Like, you know, it's sometimes these are micro optimizations, but when you have this at the forefront of your mind as a Go programmer, it really allows you to start to work with the language in the most effective and productive and efficient way, and to write code that has integrity. And so right here at the beginning, we start thinking about this, like we start thinking about the hardware. The hardware is the platform. And how is the code that we are writing interfacing with the hardware? How are the variables that we're declaring, right? How are the variables we are declaring, what are they doing in memory? And so if you look at this code, which is part of this repo right here, so you can see there's main Go right there. So if I click on that, it brings that up, right? But here's that code. And in this code, like, you know, it talks about word size and what the word size is, and how that varies for the different architectures of machines. You could have a 32-bit or 64-bit machine, and the word size is how many bits, zeros and ones, can it process at one time in one single little operation, right? How many zeros and ones? So a 32-bit machine, older machines, their word size is 32 bits. And 8 bits is a byte, so you could also say their word size is 4 bytes. Our newer machines are 64 bits, and so 8 bits is a byte, so you could say a newer machine has 8 bytes as a word size. And then we look at strings and the underlying data structure of strings here. So every string is a struct, and that struct has 2 fields in it. And the first field is a pointer to an underlying contiguous section of memory of bytes. And so recently I just learned this right here, and I capitalized this. I liked it so much. I haven't pushed that up yet. But in string, so you can see here's the code. In string, we have the first field is a pointer. It's a pointer to underlying bytes that are stored in a contiguous block of memory. And so that's like an array, but it's not an array. And that's pretty interesting. A lot of times people just talk about that as an array, but it's underlying bytes stored in a contiguous block of memory. And then the second field in the struct for a string is the length. And so it's interesting to think about that. And so then the code here explores a little bit how strings are put together. And we saw that in a previous video, but I'll go into that just a little bit. But then we also look at slice, and the structure of a slice is a 3-word data structure, right? This is a 2-word data structure up here. And a word is, right, it's going to be, a word will be on a 64-bit machine, it'll be 8 bytes. And so this is a 2-word data structure. We're going to see that. And then this is a 3-word data structure right here, meaning 3 words. It's got three 8-byte allocations, right? So 3 8-byte allocations here, 8 bytes for this, 8 bytes for that, 8 bytes for that. And so when we declare a value and we say this value, when we declare a variable and we say this variable is going to store values, and listen to the language that I'm using to talk about the language, right? We declare a variable to store a value of a certain type. And when we do that, we could think to ourselves, just kind of become aware of this, like how much memory is being used for this variable to store a value of this type. And so that's what this code here shows you. And so we'll take a look at what it looks like when it runs. I'm just going to clear this out and then just run this once more. And you can see a bool, right, takes up 1 byte of memory, and a bool will store, you know, a value of true or false, right? And then an int, and if you look at the language specification, and so we're going to go over here and just go to Golang spec and bring that up. And we go down here to numeric types right there, right? You can see we have all these different numeric types. And if you've never seen this U stuff before, that means unsigned. So down here, it's a signed one, meaning it could have a sign, it could have a negative sign. And so an 8 will store 256 different values, right? And so it's 256 here, I guess with the 0, 255 plus the 0 is 256. Because 2 to the power of 8, 2, 4, 8, 16, 32, 64, 128, 256, that's how bits work, right? That's how bits work. And it's 2 to the power 8. And if that doesn't make sense to you, you could search in the YouTube channel here for the playlist like Coding Fundamentals, something like that, and it goes through some of that stuff. So you could check that out. But a signed int will go from negative to positive. An unsigned just goes from 0 and up to positive right there. And so you have these different ones. This is going to take a byte. This will take 2 bytes. This will take 4 bytes, right? 4 times 8 is 32. This will take 8 bytes to store all that. 8 bytes times 8 bits in a byte, 8 times 8 is 64. And then down here we have an int, right? And an int, so one of the important takeaways from this video is that when you're coding, you just want to use an int. In a code smell, right, in a code review, a moment where a code review could come to a stop is if somebody's using an int 16. It'd be like, okay, this code review is coming to a stop. Why are you using an int 16 here? And because the idiomatic way to program with Go is to use an int, because an int will be the same size as an uint, and a uint will either be 32 or 64 bits. And it's one of those based upon the architecture that it's running on. And so this is an illustration about how the Go programming language has mechanical sympathy with the hardware that it's running on. If it's running on a 32-bit machine, it's going to be 32 bits. A 64-bit machine will be 64 bits. And so we go with int because, most of the time, because that will have mechanical sympathy with the machine it's running on. And there are instances where you use, greater specificity, and you really want to specify an int 64 or something like that. But that's going to be a code review stop to inquire and investigate into that, like why is that in this situation? And so looking again here, we see our ints can be, an int on my machine. This is a 64-bit machine. It's 8 bytes. And int 8 will be 1 byte because it's 1 byte is 8 bits, and that's 8 bits here. And int 16 is going to be 2 bytes because this is 16 bits. And 16 divided by 8, 1 byte, will be 2 bytes. And this will be 4 bytes, and then this will be 8 bytes. And then here's a little definition of what word is. So if you hear people using word or word size, you have an understanding of that. And then if we look at what the data structure of a string is, and remember the takeaway here, there's going to be a couple of important takeaways. One of the takeaways is you want to use int. You want to use int when you're declaring a value of type int, and you don't want to use these except for in more specific situations. But most of the time, you're just going to stick with int, and you'd have to justify why you're using something like this if that was in a code review. That's one of the takeaways. The other takeaway is that when you're declaring variables to store values of a certain type, right, you want to think about like what's going on with that. The declaring a variable of a certain type tells us the type that's going to be stored in memory and then how much memory is going to be taken. That's another takeaway. Another takeaway is when to use the short declaration operator versus when to use var. We're going to see that coming up. But those are like 3 really important, practical, applicable, use them every day takeaways from this video. All right, so right now we're just looking at how much memory is being used by these different data types and what are the different data types. And so we're going to come back and look at the string here in a second because that's interesting. But because this just came up, there are 3 classes of type. Right? And this is an ontological structure. And ontology is a really cool word. So if you look up ontology and define it, I love this word because it has 2 amazing definitions. And the first definition of ontology is that it's the branch of metaphysics that deals with the nature of being. Right? Wow, that's super cool. And metaphysics is the study of fundamental first principles. Like what is the root cause essence? Like if you get down to the very fundamentals, the basics, and it's really kind of cool. I like this word particularly in relationship to the Go programming language because Go really gets down to the fundamentals, the basics, the machine, the hardware. Like let's reduce everything to first principles. Let's keep it simple and nothing extra, right? It's got this very Zen-like quality to it, which is amazing. But ontology, I love this word because the first definition is it's the branch of metaphysics, fundamental first principles, dealing with the nature of being. And then, the second definition of ontology is it's a way of, categorizing concepts in relation to each other. So a set of concepts or categories in a subject area or domain that shows their properties and the relations between them. So one sort of, ontological structure is a hierarchy chart. And one of the cool things actually about knowing the word ontology is like when you know it and you use it in conversation, like your perceived intelligence really goes up. And so like here are some examples of like ontological structures, right? So like these are different ontological structures. So in computer science, you'd say there's computer, and then a computer could be divided into hardware and software, right? And then hardware could be divided into input hardware, processing hardware, output hardware, and storage hardware, IPOS, right? And so you start to get this hierarchy chart where you're taking one idea and you're breaking it down, and that's an ontological structure. And so here's one ontological structure for thinking about the different types. The different types, type is life, the different types in the Go programming language. And so we have built-in types, we have reference types, and we have a struct. Okay, so a built-in type is like a numeric, a string, or a bool. A reference type is like a slice, a map, a channel, a pointer. They're referencing some sort of storage in memory, right? And even though a string does reference some storage in memory, because it's immutable, we think of it as a built-in type, right? So it doesn't have these other characteristics of the reference types where you really got to think about the data and value semantics as you're working with them. That's more stuff that's covered in this GitHub repo. You could read about it. Where'd the repo go, right? The GitHub repo README here, if you go down, you'll be able to read about both strings and why they're considered a built-in type as opposed to a reference type. And you'll also be able to read about value and data semantics, also fundamental to knowing the Go programming language. And this README and what you're watching here is going to introduce you to that. So we have these three, this is the ontological structure of type, right? We have three types. This is one way you could think about it. This is like the primary way that I think about it in Go. We have built-in types, reference types, and struct, and the struct type, right? And so that's something also that's really important. So just having some precision about how we think about this. And if we come back and look at this code for what is a string, we could see right here, and I'm going to come on down. Where's my, here we go. Here's a string. It's a two-word data structure where one word is pointing to those underlying bytes stored in a contiguous block of memory, and the other one is pointing to the length. And so we could come down here and we could start to look at the size of a string, right? So here's a size of a string. When I declare a variable, right, with the identifier of f to store values of type string, I'm declaring a variable. Right? I'm declaring that there's a variable and the identifier for that variable is f, and it's going to store values of type string. When we do that, right, it's going to set it to the 0 value. And we'll look at this here in just a second, and I got to just check my time, make sure I don't run out of time. 18 minutes. Hold on, I'm going to set a timer so I don't run out of time, because if I get to 30 minutes, and the camera shuts off, so just one second. So we've gone 18. I set a timer for 10 minutes. And that will stop us 10 minutes, 40 seconds. That'll stop us so I can restart the camera. So we have a variable, and it's got the identifier of f, and it's declared to store values of type string, and this is going to set to the 0 value. So let's look at that right now just for a second. And to do that, I'm going to bring up this temporary file right here. And in this temporary file, some super cool code from a previous video. You could check out those videos, a link to the playlist down below. These are all the videos of going through the Ultimate Go Tour. And you can see here we're using the short declaration operator. So I could do a short declaration operator, and I could say, you know, this variable x, I'm going to use the short declaration operator. It kind of even looks like a gopher with two eyes, or it looks like, you know, what's that cartoon that is used in the military, the Punisher. Kind of looks like the Punisher to me. Short declaration operator, gopher or Punisher, you make the choice. But I use x is going to store a value of 42. So the short declaration operator will declare that there is a variable x, right, the identifier x, and it's going to store a value of type int, and that value is going to be 42. And the compiler will infer the type during compilation. And so you have type safety, right, at compilation time, not at runtime. And so that's again pointing us towards the difference between a dynamic versus a statically typed language. And again, at the README down there at the bottom, it talks about dynamic versus statically typed languages. And so that's a short declaration operator. You could use it in any code block, right? You can't use the short declaration operator out here. So if I was to move that out there, it's not going to like it, right? But if I bring it down here and it's giving me a red underline because I need to actually use it, because you cannot in Go have a variable declared and let that variable go unused, right? So up here I have a variable declared, and this little thing is telling me, hey, there's, you've declared this variable and you're not using it. Var WG is unused. You got to use things or get them out of your code base. But the short declaration operator can be used in any code block. And if I brought it outside of the code block, it's no longer going to work, right? Now it's telling me, like right here, expected declaration found X, right? And so it's wanting to be inside of a code block. So use in Go this is one of the primary takeaways of this video, use the short declaration operator as much as you can, right? As much as you can. And then you use var in two cases. When you're at the package level, when you're outside of a code block, you use var. So here, if I was doing some concurrency, I could use var wg sync wait group, and I could declare that up outside, right? I could declare outside, and I could even declare variables like var x, var y is equal to 42 up here like that. Like that's gonna work, right? Var y is an int, there we go, that's what I was waiting for, and it's used up there. So that's another way that I could do it up there. And var is also used, I'm just gonna get rid of those. Var is also used when you wanted to set something to the 0 value. So if I just wanted to set like var y is going to store a value of type int, and then I could print y. If you do not assign a value when you declare a variable, Go will assign a value for you, and that value is the 0 value. And so you can look up what the 0 values are for the different types. We actually have them here in this ultimate tour step 1, right? So here are the 0 values for the different types, like bool is false, int is 0, float is 0, right? Complex is 0, string is empty string, and any pointer is nil, right? That's the 0 value. And so that helps avoid certain errors when you just want to declare a variable to store a value of a certain type, and you do not assign something to it. My dog's saying hello again. The compiler is going to assign something to it, and it's going to assign the 0 value depending upon the type. So important takeaway, short declaration operator, use it inside code blocks as much as you can. Var, you're going to use it when you want to set a 0 value, right? Or when you're outside of code blocks and you're just up at the package level, you'll use var. Hang on one second. All right, my dogs got all worked up. When they see other dogs walking by, we've got like a front door. They could see through the window right by the side of it. And so short declaration operator, inside curly blocks, var when you want to set a 0 value, and var when you're at the package level. So those are some primary takeaways of this first step. And there's a lot of depth here. There's a lot of depth here. And the highlights of this first step is, like when you're declaring a value, right? You're declaring that when you're declaring a variable, you're declaring that variable to store values of a certain type. And type tells us the size of what's being stored there, and then the representation, what is being stored there. Dear Lord, those dogs. And then there's 3 classes of types, an ontological structure here, built-in reference and struct. And then the difference between declaring, assigning, initializing, like I know experienced developers who like, I don't know what's the difference, right? But you declare that there's going to be a variable that stores a value of a certain type, and then you assign a value to that type. And when you do both of them at the same time, it's initialization. And var used for the 0 value or at the package level outside of curly braces, outside of a code block, and the short declaration operator used inside a code block. And then conversion over casting. So casting is like I've stored like an int at this block of memory, and then we just say, you know what, all that stuff stored in that memory, just turn it into a float 64. And you do that at that block of memory, but sometimes you could get like hard errors that are hard to find because of doing that, because you could have overflow and you could corrupt memory. And so casting is no bueno, right? And you can do it in Go if you want using the unsafe package, named that for a reason. And conversion is when you have that value that's being stored at this memory area, this block of memory right here. You have that int being stored here, and you want it to be a float 64. It now gets written to a new block of memory down here, and now down here this is a float 64. So conversion allocates new memory and copies values into it, and it's much safer. So we use conversion over casting in Go, and there's this great quote from Bill Kennedy, which I put into that outline, which is right here, where it says, instead of telling a compiler to map a set of bytes to a different representation, the bytes need to be copied to a new memory location for the new representation, right? Which is great. So that's important. And then also we have this stuff down here. So we talked about that code review smell, and then just some good stuff that you should remember right there. Let me just see if there's anything else I want to tell you about. Hold on one second. Yeah, there is. There is something more I want to tell you about. And what I want to tell you about is we looked at like a string. And so when we ran this code right here, right, we saw that a string, when it's the 0 value, right, so coming back and looking at the code right here, var f string, we've declared f to store a value, to store values of type string, right? And we haven't assigned anything yet, so the 0 value got assigned. And we know this is the data structure of a string. So if we go here and we say, hey, what's the size of this? Right, it's going to show us that the size is 16 bytes. It's a 2-byte data structure, right? Here's 1 byte, here's the next byte, right? And then right here, you could see when we go right here and we say, hey, let's see what's stored in that. And when we show that data structure to ourselves using this code right here, right, we could see that right here, this is a nil value. There's no pointer there and there's no length there. But then when we assign a value, a string to f right here, and we run that code again, what we see is that now there's a pointer to those underlying bytes, and here's the length, it's 5. Well, here we have 2 characters. We have the H and we have the rocket ship. Well, why do we have a length of 5 right there, 5 bytes, right? Like, why is that 5 bytes? Because when you investigate that H, right, that H right here is 1 byte, but that rocket took 4 bytes to store. And so we looked at this before, and the code to do that is right here. And so that's super interesting code to look through, and it'll give you like room to grow. And and I'm going to let you experiment with that on your own, because there's another video where I talk about strings and ASCII and UTF-8 and Unicode, where I go through all of that. But here, one of the super interesting things is knowing what a rune is. So rune, that's another word that we use in the Go programming language, and this is the language we use to talk about the language. A rune is just another word for character, right? So, you know, this is a rune, right? Let me show it to you. This is a rune. That letter H is a rune, right? This rocket is a rune, right? That's another rune. So it's just another word for character. But that code right there is really great. And then if you look at a slice, and so we come up here and we look at a slice, and we do the same thing with a slice right here. We declare there's a variable with the identifier of G. It's going to store values of type slice of int. We, the programmer, do not assign a value to that variable. So the 0 value gets assigned by the compiler, right? And then what is the 0 value of that? And what is the length? Well, here's the length. It's 24 bytes. So this is a 3-word data structure. Here's the first word, which is 8 bytes, 64 bits. Here's the second word, 8 bytes, 64 bits. There's a third word, 8 bytes, 64 bits, right? It's cool. And so it's a 3-word data structure. 3 times 8 is 24 bytes. So the size of that slice is 24 bytes. Remember, what we're learning is that we are learning to think about type, right? And type tells us 2 things. How much memory is being used, right? And then also, what's the representation? What does that memory represent? What is stored there? So that's interesting. It's interesting. And so we have that 24-byte data structure right there, 24 bytes. And when we look at what the 0 value looks like and we print that out, we're not pointing to anything under any underlying array. We don't know the length and we don't know the cap, right? But as soon as we assign something to it, so here I assign some values, that slice of int to that G, right? Then we still have a 24-byte data structure, but now we're pointing to an underlying array, and the length is 4 and the cap is 4. And so there's some really interesting things to think about here, and you know, some really important stuff. And recently I served on an interview panel for a Fortune 500 company, and they needed developers who were senior level in both PHP and Go. I don't know PHP that well, so nor do I want to. But I was hired to help them in a consultant role evaluate the Go skills of the senior level Go developers, right? And so I put together a bunch of questions. Those interview questions are actually right there, so you could check that out. That could help you. I did some videos on that. And I was super surprised, like out of like however many 200 applicants, they culled down the 20 they wanted to interview. And out of those 20, like the stuff that I just covered in this video, like a lot, 18 of them didn't, I categorized 18 of them as beginner level because they didn't know the difference between a slice or how they didn't know the data structure of a slice and the underlying array. They didn't understand the ontological structure of those 3 different data types and how reference types play into things and how you have to think about data semantics and value semantics. And then it all kind of comes back to this, this first quote. I'm going to tell you about that quote in a second here, but it all comes back to that first quote right here that goes easy to learn and hard to master, right? So these are people that could have like done some pretty complex coding probably, right? With dependency injection and, they knew how to wrangle code, but they didn't know the intricacies of the Go language. And so the stuff that I covered in this video and that is covered right here in this README, man, you understand that? That's going to set you apart. And so that leads me into this last thing I want to say is that remember, nobody can stop you from learning. Remember, nobody can stop you from learning. Every day you can choose to learn. And if you learn something that's in demand, guess what? You're going to be in demand. Right? Nobody could stop you from learning. And if you learn something that is in demand, you are going to be in demand. And so I talked to somebody else who is a recruiter for a really big Silicon Valley company, and we were talking about Go, and he said, "Man, Go's where you want to be in 10 years. Like, that's what's, in 10 years, it's just going to be like, that's going to be the main thing." That's what he said to me. All right. So remember, nobody can stop you from learning. And when you learn something that's in demand, you're going to be in demand. And just to illustrate this, I had somebody recently leave me a note on YouTube that talked about that. So you can pause the video and read that there. But I was so inspired by that. I just wanted to share that with everybody because sometimes it can be hard. You're by yourself. Like my family right now is at a campfire cookout down the street at a neighbor's house, roasting s'mores, marshmallows, and doing s'mores. I was like, I got to make this video. I'll see you in 30 minutes. So here I am, right? But you do what you got to do so that you can pay rent, put food on the table, love, provide, protect, like the roles of taking care of those that you love for and provide for and protect and care for, right? Like that's kind of how I see being a dad. Love, provide, protect, And then also show up. That's part of providing. But so anyhow, I'm going to go show up now. That's this first step in the Ultimate Go Tour. I would not be where I am today if people hadn't helped me. And one of the people that really helped me was Bill Kennedy. And so Bill here, I said, I'm going to do the videos on this. I really want to share with people the Ultimate Go Tour that you put together. And I'd love to be able to give people access to your course and give them a discount. And so if you go into Arden Labs and click on training, you can come down here and click on self-paced training and go to 4 individuals. And then at 4 individuals, look for the Ultimate Go bundle. And I'm going to open this up in an incognito window because if I open it up in my window, I'm already enrolled. Because like instead of watching shows in the evening, I sit down and I watch Bill's videos. That's what I do. And if you go to have a discount code, go type in Todd McLeod and you'll get a surprise discount. So check that out. And then also if you want to take my class, so I teach beginner to intermediate. Bill teaches intermediate to advanced. Check that out. Right? Like you thought this was, thought I was going into some depth about this intro stuff. Man, Bill gets into it sometimes with the profiler and everything. So, and then if you want to take my class, come to this repo, which is the Learn to Code Go version 3 repo here, and goes to 11. And then you just want to go to the main root folder of Learn to Code Go version 3. And if you come down to the end, there's a link here to, this is my domain, but it'll redirect you to Udemy. And if you come to Udemy, you'll see my courses, including this Go course, and I have a Go web dev course, and I also just released this amazing course right here. There's a SQL course which kicks butt, and this one, Learn Git and GitHub, that just came out, and that's a great class. So I've got some really good classes, particularly though for Go. All right, that's the first one right here. Again, when you do this, if you hit run and it doesn't run, it's because the server's spooling up. And so just hit refresh and then hit run again, and then it'll come out and it'll give you the answers. All right, main takeaways. Short declaration operator inside code blocks, var when you want to do a zero value, var at the package level. And think about, right? Think about when you declare a variable to store values of a certain type, think about how much memory is being used. Just start getting your mind to start thinking about mechanical sympathy. And then also, remember that, that is telling you, right? When you declare a variable, it's telling you 2 things. It's telling you how much memory is being used and what that memory is being used for, what's being represented there, what's being stored there.